Hi everyone, welcome back. In this lesson, we're going to talk about the introduction of polynomial, and we're going to go over a few examples here, and also we're going to talk about the equating coefficient methods as well. All right. So what is polynomial? Polynomial is a general term to represent the positive whole power. So in polynomial, you could have linear, which is y equal mx plus c, right? You could have parabola, which is y equal ax squared plus bx plus c. You could have cubics, which is ax cubed plus bx squared plus cx plus d. You could have quartics or higher than that. So quartic is ax4 plus bx cubed plus cx squared plus dx plus a. Or you could have, a higher degree. So you could have ax5 and then continue bx4, etc. So all of these are under the umbrella name of polynomial. Okay. Now, the leading, there's another terminology called leading terms. So technically, the leading term is the term with the highest power. As you can see, these are called the leading term. The degrees of the polynomial is the degree of polynomial here is just the highest power. So the highest power. So you can see basically the power, the degree of cubic degree of quartic is 4, etc. Okay. A monic polynomial is when the coefficients in front of the highest power. Technically, we're talking about a. So monic means a equal 1. And as you know, lastly, the constant term is just the term that no x by itself. So we have C, D, E here. They call constant term. Okay. Here are a few examples of how to read polynomial. So P stands for polynomial and P of x is like a function of x. P of 1 means you're going to let x equal 1 in. So this means you sub x equal 1. So we have P of 1 equal sub 1 in. So 1 4 minus 3 times 1 cube minus 2. 1 to the power of 4 is 1, 1 cube is 1, so 1 minus 3 minus 2, that gives you negative 4. So P of 1 when x equal 1, y equal negative 4, okay? And then B, C, D, pretty much the same thing. Now we're going to go over this example here. So here I give you a polynomial. In this case, you can see it's the power 4, that's the degree, quartics. P of 1 equal 21. What that mean is when x equal 1, y equal 21. Find the value of c. So c is here. So we start by we let this equal 21 as the y value, and we substitute x equal 1 in. So let x equal 1. Then we can solve for c. Okay. So we have 21 equal 2 times 1, 4 minus 1 cube plus 2c times 1 plus 6, like that. And then what we do next is pretty much we just solve for c. So we have 21 equal 2 minus 1 plus 2c plus 6. 2 minus 1 is 1, 1 plus 6 is 7, 21 equals 7 plus 2c. We take 7 on the other side, 21 minus 7 is 14. 14 equal to c. So divided by 2 over, we have c equal 7, like that. Okay. We do the same thing for question B. So you can see in question B, they give you, it's like q of negative 1 equals 0. So technically they're telling you that when x equal negative 1, y equals 0. That's 1 point. And they give you another point you can see here that q of 2 also equals 0. So you are given another point that when x equal 2, the y value is 0. So technically, you are given two coordinates here, right? So we pretty much do the same thing, and we solve simultaneously for A and B. So we sub in. So -1 is the x, and this is the y equals 0. So we let this equal 0, and we let x equal -1 in. So we have 0 equal to -1, 2 times 1, 6. That's just positive. Now -1 cube, when you do that, that's become negative, and you have a negative here, so that's become +1. Okay, plus a minus b plus 20, like that. So 2 plus 1 plus a minus b plus 20. So 2 plus 1 is 3, 3 plus 20, 23. And then we move the 23 to the other side. We have -23 equal a minus b. So this is one of our equation, okay? And you pretty much do the same thing here, 2 and 0. So you substitute 2 in for x and 0 in for y. So we have 0 equal 2 times 2 to the power of 6. 2 to the power of 6 is 64 minus 2 cubed plus a times 2 squared plus b times 2 plus 20. Okay, so 0 equal 2 to the power of 6 is 64. 64 times 2 is 128 minus 2 q is a plus a times 2 squared is 4a plus 2b plus 20, like that. 128 minus a is 120 plus 20 is 140. We put it on the other side, you will have negative 140 equal 4a plus 2b. Then I divide both sides by 2 to make it easier. So -70 equal 2a plus b. So this is your second equation here. So you have the first equation, you have the second equation, then you can solve simultaneously for a and b. So if you look at this, b bring the negative, b bring the positive. So if I add them together, plus them together, the b will disappear. So if I do equation 1 plus equation 2, -23 minus 70 will give me -93. -93 equal a plus 2a is 3a. -93 divided by 3 is -31. So a equal -31. Okay. Then I can solve for a. For b, I put it back in because I know a is -31. So -23 equal -31 minus b. -23 plus 31 is 8. So 8 equal -b. B is -8. There you go. All right. Now another example here, which is p of x plus q of x. Now they give you p, they give you q, and sometimes they might want you to add the two polynomials together or take away or times it. So pretty much just copy them down and simplify them. So p of x is a whole bunch of things here, which is x cubed minus 6x plus 3. Okay, and q of x is this, x squared minus 3x plus 1. And then you would just collect like terms. So x cubed plus x squared minus 6x minus 3x give me minus 9x, and 3 plus 1 equal 4, like that. All right. For b, instead of plus, you minus this time. So px is x cubed minus 6x plus 3. Now this time you take away. So when you take away, it needs to be take away of the whole thing, okay? X squared minus 3x plus 1, like that. That's too dark. So x cubed minus x squared, right again. Okay. Minus 6x minus negative 3x. So negative and negative become positive. So negative 6 plus 3 give me negative 3x. And 3 minus 1 equal positive 2. Right. And for C, px times qx, so they want you to time together. So you can write x cubed minus 6x plus 3 times x squared minus 3x plus 1. And just like before, you can just expand them out and then collect like term and simplify them. So I'm not going to do this, but to expand, you can do like this. You can do this time this, then this time this, then this time this, and then you do the same thing for the other one. The second term you do this time this one, this time this one, this time this one. And then you do one more time, which the third term is this time this time this, and this time this. So you have 9 terms altogether. All right. Now we're going to learn a technique called equating coefficient. So here is an example here. They give you a polynomial, right? And they said that that polynomial can be written in this form, which where BCR are the real number, find the value of BCR. So because this equation equals this equation, and we need to find BC and R. So what we do is we're going to expand this out, and then we equate them. That's called equating coefficient. Okay. So I'm going to expand this one out first. I just write again here, x minus 2, x squared plus bx plus c plus r. So I expand. So to expand, I do this, and this first. So x times x squared, x cubed, plus x times bx is bx squared, x times c is cx. The x refer to b at the back. And then after I do that, I do negative 2 times this, negative 2 times this, and same thing. So I have negative 2 times x squared, negative 2x squared, negative 2 times bx is negative 2bx, negative 2 times c, negative 2c plus r. Okay. Now, now I look at this and I say, oh, that have to be equal with this. So that's equal x cubed plus 3x squared plus 2x plus 1. All right, so you can see both, if you compare the left and the right, the both of them have x cubed. So I don't have to worry about that. Okay, now I'm looking at the term that have x squared. So you can see the term that have x squared is bx squared and negative 2x squared. So that tells me that when I add these coefficients together, b and negative 2, that have to give me the coefficient on the right, which is 3. So from here, I can say that b here and minus 2, if as a coefficient, that have to be equal to 3. Okay. So b minus 2 equal 3. So b have to be equal 5. I'm done that. Now I'm going to do the next term. Oh, sorry, just delete this. Okay, so the next term is 2x. So I'm collect all the terms that have 2x. So I have cx here, and I have negative 2bx here that have the variable of letter f. So what that show me is c, the coefficient c, minus 2b as the coefficient of x. That have to be equal to. Okay, and I know b equal 5. So I have c minus 2 times 5 equal 2. So c minus 10 equal 2. C equal 12, like that. Now keep going. Now I'm doing the last term, which the constant, which is one. So you can see the constant that have one is doesn't have letter x in it, which is negative 2c and positive r plus r. So I would have negative 2c plus r give me 1. And I know it's equal 12. So negative 2 times 12 plus r equal 1. Negative 24 plus r equal 1. So r is 1 plus 24 is 25. Okay, so that's how I expand and collect line terms and then equate them. So here is another example, and I pretty much do the same strategy. Feel free to pause the video if you need to have a go first. Now, pretty much the same thing. They give me this equal this, and they want me to buy A and B. So here I would have, so A, x plus 1 q plus B. Okay, now I expand this out. So A, x plus 1, x plus 1 cube. If you remember the formula, or you can just expand manually, A plus B cube equal A cube plus 3a squared b plus 3ab squared plus b cubed. So if I have x plus 1 cube, I just use the formula. So I have x cubed plus 3x squared times 1 plus 3 times 1 x squared plus 1 cube. So I simplify that x cubed plus 3x squared plus 3x plus 1. Okay, all right. Um, So x cubed plus 3x squared plus 3x plus 1. And then I have plus b. So here you have a x cubed plus 3ax squared plus 3ax plus a expand all and plus b. Now you equate them. So I have, what do I have? I would have that have to be equal to this x cubed plus 3x squared plus 3x plus 3 plus a, sorry. So you can see x cubed, can you see? Ax cubed, that have to be equal x cubed. So the coefficient of x cubed here is 1. So we know a equal 1. So we done that. This one is gone now. Okay. Now we do the next one, which is 3ax squared, and this is 3x squared. So we see 3a is a coefficient equal 3. That gives you a equal 1, which is exactly what we got. Then 3ax equal 3x, that's the same thing. 3a equal 3, that still gives you a equal 1. Okay. And the last one is a plus b equal 8 as the constant. So a plus b. So what do I have? A plus b equal 8. A equal 1, 1 plus b equal 8, b equal 7.